Hi guys, welcome to Parent Functions. Each day we're going to do two parent functions. You're going to use the coordinate planes to try to practice with them, and then you're going to use the graphing calculators to see if you can get the same answers that I do. You'll also be given some papers to put into a booklet so that you'll have these so that when you do your project next week, you'll do very well. So the first thing I want you to do is I want you to go ahead and pause the video and follow the directions on the screen. I want you to work with your partners and create the following functions on a coordinate plane. And I want you to try to use different colored rubber bands. And I want you to discuss the transformations that happen to this original function of f of x is equal to x. Hi, welcome back. This really should be kind of what you should see at this point. The black one is the original function, and each of these has caused a transformation. Now, let's go ahead and keep that where we can see it, but then use the sheet of paper and the graphing calculators to see what we can discover. All right, this equation, the parent function was f of x is equal to x. And hopefully at this point you knew that that was a linear. Okay, so when I graphed that, when x was equal to 0, y was equal to 0, and so on, and so on, and so on. And what we noticed is that we ended up with something that looked very similar to this. And then we went ahead and graphed it with a line. And what we should have noticed is that oh, Mrs. Rose, that doesn't really look very good at all, does it? What should you have noticed about the domain? Talk to your partners about the domain. Well, since this goes to infinity and beyond, there really was no restrictions to the domain, was there? And there was also no restrictions to the range. So when I have that, the domain went from negative infinity and traveled to positive infinity. And the range also was negative infinity all the way to positive infinity. Now, what about the y-intercept? It intercepted at 0, 0. And of course, the x-intercept was also at 0, 0. All right, so let's talk about the symmetry, and even, odd, or neither. Well, ladies and gentlemen, it crosses through the origin, and it does have 180 degrees rotation, so it is an odd function. And of course, the symmetry is around the origin, and that kind of goes back to what we talked about last week. Now, is it one-to-one? Now, ladies and gentlemen, we haven't really talked about one-to-one functions, so you might want to jot this note down where it says important notes. One-to-one function means that it can pass a horizontal line test. And that means for every x value, there is only one y value. And for every y, there is only one x. And so, yes, this is true, okay? Because we have unique, oops, let's do a Q, unique x and y, all right? Now, increasing, decreasing, or constant over what interval? Well, we look at this, and ladies and gentlemen, of course, with this function, it is increasing over an interval of, that's right, negative infinity to positive infinity. All right, so what happens if we negate x? What happens if we negate x? Well, I want you to go ahead and use the graphing calculator. And what I want you to do is to go ahead and put these two equations into the graphing calculator. Now remember, to get this solid line, you just go ahead and arrow over to the left and hit enter until you see the solid line. Go ahead and pause the video until everyone has that in. All right, welcome back. Now, what I want you to do for graphing this, and this is very important that you pay attention. I want you to hit the zoom button, and then I want you to hit the number 6. All right, did you do that? Then, of course, this is what you see. So, what happened to the original equation? Well, hopefully what you realize is it reflected over the x-axis. So what happens if A is negated, and A, of course, is the number 1? It reflects over the x-axis. Go ahead and pause the video for just a few moments and go ahead and create your graph here. All right, well, what happens if we change the absolute value of A? Now remember, the value of A is the coefficient of X. And what happens if we make that greater than 1? And what if we make it a fractional component between 0 and 1? Go ahead and go to your graphing calculator and go ahead and put these values in. Now, ladies and gentlemen, remember, in order to get this little symbol here, you're going to have to arrow over to the left and hit enter, and then hit enter again until you get this symbol. But what I want you to do is I want you to put the functions in x, 3x, and then parentheses 1 divided by 2, which is 1/2, parentheses, and then x. Go ahead and stop the video until everyone gets it in there. All right, welcome back. Let's go ahead and hit zoom 6. And when you hit zoom 6, this is what you should get. All right, so ladies and gentlemen, what does happen if you do these things? Well, if you have greater than 1, notice that the slope gets steeper. That is called a vertical stretch. It is stretching towards the y-axis. Okay, so if I do a fractional between 0 and 1, that is called a vertical shrink. And what it does is it shrinks towards the x-axis. Go ahead and do your graphing right here. Pause the video, and then we'll move on. All right, what happens with a vertical shift? Well, let's go ahead and try this. Go ahead and pause the video and just go ahead and do these 3 functions. All right, if you go ahead and hit zoom 6, hopefully this is what you'll see. Talk to your partners about what happened. That's right. If you had a positive number, it shifted up. There was a vertical shift up. If you had a negative value, you had a vertical shift down, okay? So somewhere in here, I want you to write that if you have a positive k, that means a positive value k, it shifts up. And if you have a subtract k, you have a shift down. Go ahead and, that's right, do your graphing and show the results. Welcome back. What happens with a horizontal shift? Ladies and gentlemen, this is a trick question. For a linear function, the horizontal shift depends on the vertical shift. Okay, that is huge. That is a trick question. All right, so in your important notes, I would like you to write f of x is equal to a x plus k, okay? And let's just kind of review what you had. If a is positive, it will increase from left to right. If A is negative, it will reflect over the x-axis and decrease left to right. If the absolute value of A is greater than 1, it is a vertical stretch. If the absolute value of A is between 0 and 1, it is a vertical shrink. Okay. If you have K is greater than 0, that is a vertical shift up. And if K is less than 0, that's right, it's a vertical shift down. Okay, great job. We're done with linear functions. If you will go ahead and skip to the next video is exponential functions.